So there's a couple of ways you can do this. You can do it with double-sided tape, as I just explained, or you can also do it with contact adhesive. Sometimes double-sided tape doesn't work too well if you've only got a thin gap like this. So we're going to do this with contact adhesive, and it's a bit tricky because I need to only get it really on the actual surround. Then you let it go really tacky and you work fast. Okay, so the sometimes better thing about using contact adhesive is you don't really need to clamp it so much. You tend to be able to, if you get the contact adhesive really sticky, you tend to just be able to do it all in one go, but you do have to work quick. So I'll just wait for this to go nice and tacky. Right. It's the corners you've got to get right. Right, okay. This is only just long enough. Just check that grain, perfect. Don't look too pretty at the moment, but don't worry. We'll get there. With the contact adhesive as well, it's probably a bit better for the corners because the glue will soak through the material and allow you to really get those corners down nicely. Right, that's good. You do have to stretch it over quite a lot. You do have to lift it and re-stick it. Just try not to do it too many times, because every time you do it you leave a bit of the material behind, and eventually there'll be no glue left for it to stick to. Right, okay, that's pretty damn good, and the grain's good as well. Right, so what we do, really work these corners down, and then we'll run around that with a sharp knife. And then normally what I do as well is put the knife tip on the soldering iron and run around it with that as well, which gets rid of loose threads. Right, okay, that's what we end up with at the moment. Still good on the front. A little patch there where it hasn't stuck. If that happens, what you can do, let's try and find something to put it on with. Like that. Okay, so that one, apart from tidying it up, is done. The leftover glue we'll just clean off with some alcohol. Easy. Right, so these are the woofers that I've ended up choosing for these, and made by Vifa. They are the P17WJ-00-08. These are an 8 ohm variant. I don't think there's a 4 ohm. I did look, I couldn't find one. So we're going to use the 8 ohm version, which the original was a 4 ohm driver. We're not using the original crossover, so we're going to start from scratch anyway, so it doesn't matter that these are 8. As long as that doesn't run us into volume issues with the tweeter. I don't think it will, because there was a couple of resistors in series with that, so they were pulling the level down anyway, so I think we'll be okay. So yeah, it was important to find something with a polypropylene cone, because these really do play up high into the mid-range. The polycell tweeter on these doesn't play very low. Really wouldn't want to use it below 3000 Hertz. So these are good up to about 4,500 before distortion starts to creep in. So I think these are going to work well, and they're just a better driver as well. I scoured around for these new. They're about 60-70 quid each, but thanks to the power of eBay, I was lucky enough to find a pair of these second hand, and I think I paid 55 quid for them, or was it 50? Can't remember. So I'm really chuffed with these, and they look nice. Obviously same size chassis, cut out and everything. Unfortunately the holes are slightly misaligned, or these are further out than the original, so I can't use the original holes, but that's not a problem. I can just turn this 45 degrees, recenter it and remark it. So what we do, we'll solder some lead wires onto these, so then we can set it up in front of the microphone and get our crossover designed and built. So while we're waiting for the iron to warm up, like I say, these are the original holes, which we can't use because the holes on the new drivers are slightly further out. So whilst I can just see the holes, I can't get the screw in there. So what I need to do is just turn the driver 45 degrees. So what I've done is found the centre here and marked us a line, like so. Then lined that line up with this screw here to find the faceplate centre. Marked it there, so I've got 2 points to line up our screw holes, and then we can mark the others as well. But yeah, that's what we're going to have to do, and these look pretty nice in there. So we are like that, and I think that looks pretty damn good. These should work really well. And now we've got the new cloth done, which is looking really sharp. They're going to be, yeah, pretty good. These holes don't go all the way through, so I'm not worried about air leakage. You've stolen my screwdriver. These chipboard screws are actually, the heads on them are a bit too big. I don't like the look of them, they overhang too much. So I'm changing them for something with a smaller head. Right, so that's screwed down really nicely. We're even all the way round. Yeah, these screws are better. I might actually replace them again with some newer ones, because I have actually used these, but for the time being this is in there properly, and now I want to get the crossover built. But yeah, I think that looks a lot better than the original. So, you know, this was a gasketed driver, really designed to be mounted underneath, and this is a sort of faceplate mounted driver, baffle mounted driver, so the finish on it's a lot better. So yeah, happy with that. Probably worth mentioning while we're here, that's the original binding post, just spring clips, you push your wires in, and the crossover's mounted on the back of that on a little board, Nafio components. So I've got some nice new binding post cups to go on here, so we can get a banana plug in there, or you can unscrew them and get your cable in, and they fit on there perfectly. Same screw holes, I think. Yep, so that's good. Obviously our new crossover is going to be on a new board inside, so yeah, just a last update. So what I'll do, I'll block this off, and then we are ready to connect it up and get this crossover done. Right, so they're both all in together, so it's time to get the crossover done. And those woofers are looking really good. Like I say, I'll probably put some better screws in there, but yeah, pretty good. As you can see, we've got quite a bit going on at the moment. So yeah, all good fun. Right, so I've got the Infinity RS 2000 on the stand ready, And what I'm going to do is shoot some near field measurements first, so I can really get a good understanding of how these drivers are behaving, and then we can look at what sort of crossover frequency we're likely to shoot for, and then start to build from there. So cables are connected at the back, Crocodile clipped on, all ready to go. And once again, I'm using my custom built crossover board. So we have our negative rail here, so our amplifier is connected here, positive rail up there, tweeter, mid-range, but we're not doing a three-way, and woofer. So that gives us our tweeter terminals, mid if we were using it, woofer. So I can build the crossover with all our jumper leads, with all the various components I've got there, and keep measuring, testing, and then we can, off the back of that, actually build the proper crossover after some listening, and there's always some tweaking. It's a nice day outside, so normally I do these measurements outside so I can really measure full range with no room interaction, but it's windy, as you can see, so that's no good. So yeah, this will be all right, so we'll get cracking. Right, so we'll check the woofer first. So we've got these woofer connected to the negative here and the positive up there. So let's do a near field measurement on the woofer. So I've already checked our levels. Okay. Now, well, you can see that. So if we time align that and put 6th octave smoothing in, wow, that's actually really good. I don't know how well you can see that. Let me just change the axis a bit, or the limits. Right, so at 1 kilohertz we are about 91 dB, and I would say we're between 88 and 90, so plus minus 1 dB, call it 1.5, up to about 2K, and then we roll off. That's pretty good. Let's have a look at. Right, so phasing goes a bit crazy from 3.5 onwards, so really we want to start rolling this off probably at 2.5. And how's the distortion? Yeah, so about 2.5. Right, okay. Yeah, all right, so pretty clean. That's good. Right, nice. Okay, let's have a look at the tweeter. I'll just call this woofer near field. Okay. Right, so tweeter's connected now, woofer isn't. It's really important when we do the next measurement that we adjust the start frequency, probably to 1500 hertz. Otherwise we're going to pop our little tweeter. So we're going to measure from 1500 hertz up to 20 kilohertz. So let's see what we've got. Right, so I've just done the sweep on the tweeter and it's playing really loud, so which is to be expected. So what I'm going to do, I've just put a 4 ohm resistor in series. Okay, that's better. Right, and let's apply some smoothing to that, time align it. Okay, right, so we're really high, which is to be expected, but I don't know how well you can see that. We're kind of, I don't know, about 4K. We don't want to use it much lower than that. Let's have a look at its spectral decay. Yeah, so we've got some ringing at about 2.5K. So really I want to roll it off before that. So yeah, going to be interesting getting these to meet. So Yeah, okay, right. I'm going to crack on with this and let's see what happens. Right, little update on where we're at. At the moment, the green line is the sum of everything. And you can see our tweeter's right up here at the moment. We've got a bit of a dip, and then the tweeter rolls off. Then our woofer rolls off quite steeply. I've got a second order filter on both of them at the moment. This is really steep, so I need to roll that off a little bit more gently. But we're summing up fairly well at the moment, but we've got this issue here. But that's actually there with the tweeter already. So I'm going to have to try and pull these two peaks down. So it's going to be quite interesting. Right, that's where I am at the moment. You probably can't see that particularly well. Still got an issue here, but really from, what's that? Let's say 8 kilohertz all the way down about 300. I'm within plus minus 2.5 dB. Some of these bits here are just the room. If we look at the near field woofer, you can see how nice and flat that was within a 2 dB window. So this is room interaction, I'm afraid, but I've learned to kind of understand that and live with that. But yeah, really good at the moment. I'm trying to work in this little dip that I like, from like 1000 up to about 3. It's I suppose it was called the BBC dip. It's where the 2000 hertz range is where we're all a bit sensitive. It's shouty, so I like this little dip. But yeah, what's going on here I need to work on. So at the moment I'm second order on the woofer and second order on the tweeter. I've got a resistor in series as well, but yeah, I need to have a play with that tweeter. I think I'm probably going to have to use some form of notch filter at the top there to pull it down a bit, but I don't really want to do that. It's just more stuff in the signal path. So yeah, I'll persevere and see if we can improve that little bit without doing that. Whether you hear that too much or not, because it's right up at 8K upwards, I don't know. Probably not, but it would be nice to just pull this down a bit and raise that up a bit and possibly bring the overall level down. But yeah, getting there. Right, I think I'm going to stop mucking around with this there. I'm quite happy with that. Right, so 80 dB, I could change this so it looks a bit better, but anyway, 90 dB, and we are pretty much from 200 hertz right the way up to 15k, plus minus 2.5 dB, and I've got this little dip that I like, and that has been a lot of cocking around with the roll off for the tweeter. It's been really difficult to work with. I've tried so many different things, and we've got a good phase relationship there. So the tweeter does run out of phase, so we're crossing about 2.8 to 3k, which is a bit higher than, sorry, a bit lower than we would have had originally. But what I'll do, I'll quickly shoot individual measurements and we'll see where we are. Right, so I've just done the individual drivers. So the brown line here is our tweeter. So by mucking around with the second order, the inductor, down to ground, I've managed to kind of fold that down a little bit. I can go third order and get more of this out, but then I cause a phase problem with the woofer, and it's kind of the best of, or lesser of two evils, I should say, with what we've got, and our woofer's rolling down at about 3. Possibly I could pull this back a little bit, but I think overall we're working quite well. So I need to do some off-axis measurements and make sure that we've not got any big holes appearing or anything like that. But really, if I turn off that and that, yeah, I'm really happy with that. So in terms of phase relationship, what are we looking at? Very pleased with that. Spectral decay, bit of ringing. That's possibly just something in the room here, because I haven't stuck all my sheets up and everything. So, and that is quite a bit down as well. So yeah, not too worried about that. Yeah, looking very good. So I think I'm probably going to call that it for the time being. So in terms of the tweeter, we've got a 3.9 ohm resistor into a 5 microfarad microfarad cap, which is what we had originally on the original crossover. But then I've got a really small inductor, 0.08 millihenry, and the tweeter's out of phase. And then on the woofer, I've ended up with a 5.5 millihenry, although I might play with that and use something larger. And we have a 6.8 microfarad cap, so second order on both, which is good. It means the signal path is nice and clean. So yeah, I think we'll call that it. I might tweak this a little bit, do some off-axis measurements, but otherwise this can go together. Cool.